Hello, everyone. Thank you for coming here today. Welcome to When View Models Go to Die, Saving View Model State. So for those of you on the West Coast, I hope you have a nice lunch in front of you. Everybody else, try and grab a coffee. Today, we are going to talk about SavedStateHandle from Jetpack, but we're also going to cover some background information on process death and state management, what that means for view models, and how SavedStateHandle solves some of these problems for us. I'm going to do some live coding, and we will have about 10 minutes at the end for questions. So let's get started. A little bit about me. My name is Sumayyah Ahmed. I'm an Android engineer at Comcast in Philadelphia. I've been making Android apps since around 2013, about like KitKat days. Fun fact about me is for the entire first year, I was a mobile app developer. I didn't have a smartphone, so I would run all my apps on an old Samsung tablet. So very happy to say that times have changed, and I actually have a real phone now. SavedStateHandle is a new Jetpack recommended way of handling state management with view models. And when I say state, I don't mean state as in, well, we heard a lot of definitions of state over the various talks yesterday and today. But when I say state, I mean a particular state that the user could be in on your screen. So if the user is on the screen and they have selected, item 1 in a list, that's a state. If they go on and select item 2, that's a different state. Now, um, you could imagine that all the possible user flows are a state machine, and all these discrete things that the user could do is a particular state. But in the old days, let's think about before view models happened. We would have activities and fragments. These are views, and views get destroyed and recreated all the time, right? We go through configuration change, we go through background, foreground. So these views are getting destroyed, these views are getting recreated. They're not static. However, a particular state doesn't correspond exactly to your activity lifecycle. So a user could be in a single state. The activity could be in the background, come back to foreground. So the activity is going through a bunch of cycles and a bunch of changes, but the state remains the same. There's no one-to-one correlation. And similarly, your activity could be in the foreground the whole time and move through a variety of states. So for those of us who are developers and trying to manage state at this time, it required us to override lifecycle callbacks, keep track of where in the lifecycle the activity or fragment was, and save our state if necessary, restore our state if necessary. So this was, first of all, cumbersome, error-prone. It violated best practices. So when view models were first introduced in Android architecture components, they solved a lot of these problems for us. So first of all, we were able to separate out our state management, our business logic into a separate class that was still lifecycle aware. And we were able to keep our views as dumb as possible. The views would no longer have to care about state management, and the view model would no longer have to care about lifecycle per se. So our view model would be guaranteed to persist our data or persist our state through rotation cases, through background, foreground. But there is one case that view models aren't guaranteed to handle by default, and that is process death. And when I say process death, I mean system-initiated process death as opposed to the user force quitting an application. Let's dive into process death a little bit. The Android OS runs a version of Linux. So every application that you have runs in its own Linux process. Facebook is process 1, Instagram is process 2. Your application is process 3, for example. Now, your application is going to run in the real world with resource constraints. This is a unique problem in the mobile world. We saw Chethass and Romangi talk about this in our keynote a little earlier. But the real world means resource constraints. Mobile applications have limited resources. And what happens in this case is, let's say the user is running your application. He or she throws your app into the background, and starts playing a video game, for example. This is a very resource intensive process. And what the OS will do at this point is try to free up resources by killing background applications in the background, killing those processes, which could be your app. What does this mean for our view models? So generally, a view model with its status data, so for example, a view model with live data, with properties, and a view model that maintains state with these live data and properties, runs in your in-process memory. If the Android OS kills the process, as we just talked about, this memory is gone. Usually this memory is an LRU cache. So this cache is wiped out and your view model is completely reset. So all of these live data that you have been updating with from your activity, from your user interactions, are suddenly back to zero. And you've lost all of that context that you've been holding onto our view model. This is, of course, a problem because users expect that when they bring your activity back to the foreground, they can pick up where they left off. So for example, let's say they were typing something in a search bar and they saw a list of results. If they encountered process death, that search bar would be empty and there would be no list of results when they came back to the application. And not only is this slightly a disruptive experience, it has implications that are much more important. So this sounds like a trivial use case. But in the IoT space, we often have situations where we use mobile apps to set up Bluetooth-enabled hardware. So you would have a situation like this. The user is being guided through a series of steps, and the hardware correspondingly moves through a series of steps. So your view model has the user in step one. Let's say the user has completes some interaction on screen, the view model moves them to step two, and your hardware, say it's a router, moves into state two. Now process death happens for whatever reason. All of a sudden, your view model has no clue where the user left off, but your hardware is still stuck in state two, and you can't obviously rewind. So now your app and your hardware are out of sync. So as you can see, not considering process death in our development process can have serious implications for not just the usability and the delightfulness of our applications, but also the ecosystem in which we expect our apps to operate in. So how do we test this in our normal development workflow? I'm going to show you right now. I'm going to pull up a code demo for you, and we'll see how to test for process death. I have a very basic application here called SavedStateDemo. Let's ignore all this code for a minute and focus on just the application. So all it asks the user to do is type in some text. Let's say you say hello. When we hit save data, we are saving this text in a live data. When we switch over to our view model, this view model represents our screen. As you can see, it's very, very basic. All it does is maintain a live data for this text, which we now have as hello, hello, and it exposes a save function for the view to update with the current text. Now I'm going to rotate the phone, and whoops, this just disappeared. As you can see, this survives rotation as expected. I'm going to background and foreground the app, and the view model does its job, which is really great for the majority of use cases. But now let's try to simulate process death and see what happens. Let's switch over to the terminal here. And my preferred way of testing process death is through the ADB kill command. First, let's run the grep command to see what processes are running at the moment. When we run grep, you can see that there's one process running with our package name, which is com.example.savedStateDemo, which is great. Let's background this application and run the ADB kill command. And that's ADB shell am kill com.example.savedStateDemo. So we've run the kill command. Now I'm going to grep again to see if the process is still running, which is not. That's expected. And we bring this back to foreground. And as you can see, our view model has lost our data. So this saved text is completely wiped out. That's not a great experience. So how do we mitigate this? One option is to persist this data in either your shared preferences or your local database, but this violates best practices. View models are meant to store transient UI related data. So, for example, something like the current text in your search bar or the current selection in a list, for example. So none of this is stuff that you would care about once that activity is gone and finished. It's important within that activity, but it's really a waste of storage space to persist it permanently. The recommendation is to use saved instant state because saved instant state is guaranteed to survive both configuration change and process death. Let's see how it works. Oops. So you would have your lifecycle owner like an activity or your fragment with an associated view model. And that lifecycle owner has an associated saved instant state data store. So when you go through process death, you lose your lifecycle owner, you lose your view model, but saved instant state survives because it's serialized to disk. So when your activity comes back into the foreground, you're able to use that saved instant state data to restore state in your activity and to restore your view model. And let's see how this looks like in your code. So typically you would have your view model, you would attach it to your activity, you would have to attach it to your activity and override on save instant state. So you would get the data from your view model, serialize it, attach a unique key, save it in the bundle, and you would do the whole process in reverse for whenever your activity comes back to foreground. As you can see, this is really cumbersome. First of all, you have to remember to do this. Also, let's say something changes in your view model. You add a live data, or you change a type, or you remove some variables. You have to remember to update this in your activity as well, or somebody who's a completely new developer coming into this code has to remember to do this as well. That's not the only problem with saved instant state. There's others as well. So now your view class has got data logic and storage logic. Your view class now has to maintain state. It has to be responsible for communicating with the view model about what state is, like what the view model needs. So this is not really ideal. It violates a few of our best practices, and it's not the easiest way of doing things. There's a lot of overhead. Jetpack's solution to this is to use the SavedStateHandle library, which solves a lot of these problems. So what is SavedStateHandle exactly? SavedStateHandle is an interface. It's essentially, behind the scenes, it's a map of key value pairs backed by bundle. Now, if this sounds familiar, that's because actually it is. There's a lot of classes that are introduced in this library, and we'll go into detail later, but essentially, this is a view model friendly wrapper around saved instant state. You have access to a data store that's guaranteed to survive process death and configuration change, but it also allows view model a direct handle to managing its own data. So the view model no longer needs to care about where your life cycle is at, and your view no longer needs to care about the view model. Your view model can be used just for business logic, and it's now completely data independent of your lifecycle owner. Let's see how we use it in a really basic way. So by default, the library gives you access to a constructor argument, SavedStateHandle, in your view model. You have simple functions to read and write from this library. You just have get and set, and you use unique keys to identify your data. As a bonus, you also have built-in support for live data. So this reduces the amount of work you have to do in your view model. I've been talking for a while, so now let's do some code. Let's go back to our saved state demo application, and we'll make it process death proof. So if you remember, this is our very, very simple application. We have a simple view model, and this is the data that we lost on process death. And now our objective is to make this view model and all of its data process death proof. First things first, let's make sure we have the right dependency. We'll go into our build.gradle. It's yelling at me for a lot of things, but we just focus on this. So we need this lifecycle view model saved state dependency. And for reference, the version I'm on is 2.2.0. It's now stable. And it also has a dependency on the Android X library. Now that we have added our dependency, let's go to our view model. And we now have a constructor argument, SavedStateHandle, passed in by default. And this handle is going to be our single source of truth for all the data that we want to persist or save. As we talked about, we want to save this text here. So let's make a unique key for this. And we'll say const val key equals key. And in our save function here, instead of updating the live data, we are going to say handle.set, and we're going to pass it the key and our current text that's coming from our view. Now that we've set our data, last thing is to use the save state handle as our source to read this data from. Now we want to maintain a mutable live data here because that's what our view expects. So we'll say this is a mutable live data of type string. And we're going to say handle.get. There's three function signatures here. We can say get, which returns just a primitive type, but we want a live data. We can say get live data with a key or get live data with a key and an initial value. That's what we're going to do here. So we're going to say key and initial value is init. That's literally all we have to do as far as the view model goes. There's just one last piece of the puzzle here, and that is this. So where on earth are we getting this SaveStateHandle constructor argument from? And the answer to that is a factory. Let's go to our fragment class. This is, of course, a very, very simple fragment. All we're doing is declaring our view model and initializing it here. We initialize some view objects, and we set our observers. So we're observing the saved text, live data, and we set a click listener on save button. Now with saved state handle, none of our view code needs to change. All of this can remain as is. The only thing we're going to change is the way we initialize our view model. We're going to delegate it to saved state view model factory. This is given to us by default from the library. It requires two constructor arguments, an application instance, so we're going to give it the application here, and a saved state registry owner. We're going to talk about saved state registry owner a little later, but think of it as your lifecycle owner, and which in this case is going to be your activity. So just to recap, we added a dependency in our build.gradle. In our view model, we added the default constructor argument, and we made sure to use that constructor argument to set and get the data that we care about. And the last step was to actually initialize it with the correct factory. So now that we've done the code that we care about, let's run this application and we shall actually test it out and see if it's running as expected. This is the fun part of any presentation, is the live coding. So install is almost complete. And as you can see, this is respecting our init initial value. Oh, whoops. Let's bring this back up. And again, we initialize our text with init. And let's type in some data. Say hello saved state. We're going to hit save data. So presumably now this text is saved in our handle. Let's background and foreground the application. That works as expected. Now we're going to simulate process death. So again, I'm going to run the grep command to check our running process. That's perfect. Let's put this app in the background. We're going to run the kill command and then grep again. So as you can see, nothing turns up. We'll bring this app back to foreground and our data survived. So as you can see, it is a much better experience for the user. There's one other common use case that I'm going to run us through, and that is, what if our view model has already got constructor arguments? Let's see how that would work. So I'm going to create a new view model. Let's just copy this code here, and I'm going to create a new class and call it constructor args VM. Create a new class. We're going to zoom in and paste all of this code here because essentially it's the same as our old view model. The only thing that's going to change is, let's add a new constructor argument. Let's say we want to pass in the initial text to the view model. So instead of hard coding it here, we're going to use initial text. So that part's done. Again, where are we going to construct this view model? We can't use SavedStateViewModel factory, but we can create our own implementation of abstract SavedStateViewModel factory. So let's go ahead and do that. Create another new file, and we're going to call this one constructor args VM factory. Create a new class, zoom in again. This extends abstract SavedStateViewModel factory. Guys, these are really long names, which takes in a registry owner and some default arguments. So let's add some arguments to the factory. First of all, we want our initial text, which is of type string. We also want a registry owner, which we're going to pass into the abstract saved state view model factory. So we're going to pass it a reference to the lifecycle owner, and we'll say null for the default arguments. The last part we need to do is to override the create function right here. And as you can see, the create function is where we get this SavedStateHandle instance. There's some magic going on behind the scenes, but as far as we're concerned, we're able to construct our view model with everything that we need. So let's return constructor args VM with initial text and a saved state handle. And we'll cast it to the correct type. The last part is to hook all of this up with our view class. Let's go back to our fragment. Again, all of our observers, our click listeners, none of this logic is going to change. We just need to change the way that we declare our view model. So we're going to change this to constructor args VM and use our factory instead. Constructor args VM factory. This asks us for an initial text and a registry owner, which in this case is require activity. So just to recap, we created our view model with constructor arguments here, what the constructor arguments we need, and the saved state handle that we get by default. We extended abstract saved state view model factory, and we hooked this all up in the view by using our own custom factory. Now, in the interest of time, I'm not going to test this, but instead, let's dive in and see how this works behind the scenes. So as you can see, we're still using saved instance state all the way here on the right. But there's a bunch of new classes, so let's go through them step by step. Way over on the left, we have a saved state registry owner. This is essentially your lifecycle owner plus a reference to saved state registry controller. Now, the job of the registry controller is to maintain a list of saved state providers. Each of these saved state providers will wrap up its own data into a bundle with a unique key. the registry controller will wrap all of those bundles into a master bundle, which is then saved in saved instant state. So if you remember, when we constructed our view model, we passed it a reference to the registry owner. And the reason for that is so that the saved state handle that's associated with the view model is included in this list that's owned by the registry controller. So when your activity goes into the background and hits the onStop lifecycle method, the registry controller will start iterating through its list of providers. Each of the providers will produce a bundle. So the registry controller will take the list of bundles, wrap it all up into a big bundle, save it in saved instant state. And when the activity comes back to the foreground, the same process happens in reverse. So our saved instant state gets unwrapped into a bundle. Each of these is unwrapped into the smaller bundles. And because there's a unique key attached to it, the saved state provider behind the saved state handle knows which data to get. And saved state handle is essentially just an interface. So the view model gets its data directly. Now, as you can see, the view model doesn't care about any of the other things going on here. It doesn't care about the registry controller. It doesn't care where the other providers are coming from. All of that is abstracted away. The view model's job is to maintain state for the UI and use the saved state handle to persist this data. The view, likewise, doesn't care about any of these things going on behind the scenes. All the view knows is that just by initializing itself as a registry owner, the saved instant state logic will get taken care of. So essentially, saved state handle makes it not just easy as a developer to write clean code and write code that follows best practices, but it also ensures that by using saved state handle, we're creating a delightful user experience, and we're creating more robust applications that are, that can survive real life situations. Now, of course, there are some limitations here, the same limitations that apply to saved instant state. This is only for simple data types like primitives or parcelable objects. Also, there's a data limit. So this is not meant to serialize a whole list of images or a whole list of MP3s. That's not really what saved instant state is for. And also, it's not a permanent form of storage. So when this activity, which is essentially your registry controller, when that is gone and finished, the saved instant state is also gone. So this is only meant for, again, transient UI-related data. But by using saved instant state, again, it's convenient for the developer. It enforces best practices. It's a lot of fun to use. It's very easy to use. And it just ensures that the end user has a delightful, a robust, consistent experience at the end. So I hope you have as much fun playing around with saved instant state as I have. Feel free to check out the Google developer documentation. Christian Garrido did a talk on something related on activity life cycles yesterday. Check that out as well. And now I am going to wait. We're going to have some questions coming in, and I will do my best to answer your questions. So we have some questions here. The first question is, does the transaction too large exception for saving too large bundles also apply on saved state handle? I talked about this a little bit in my limitations slide. Yes, it does, because it's backed by saved instant state behind the scenes. You cannot or should not save data that's too large. So for example, if you have a recycler view with a list of images, it would not be appropriate to try and serialize these images with saved state handle. You would probably get a transaction too large exception. Let's see, a second question coming up here is, will this use case also be applicable for user-initiated process death, as in a force close? The short answer is no. The long answer is Android considers different use cases for activity closure. So a user-initiated forced close is in a different category of closure than process death. And just to go into a little bit of background, it has to do with the OS activity manager. So if the activity goes into the background and system initiated process death happens, activity manager still retains a reference to the activity that you lost. So when you come back to that application, the activity manager remembers that you were on this activity and you had certain data related to this activity. But if the user force closes or presses the back button, this doesn't happen. So the OS considers that as a final close. You're done with that activity. You don't want any of that data anymore. Next question. Could you share some complex scenarios of using this where it could help to prevent fatal exceptions? This is a great question because we're talking about like side effects of process death. Most of the time, you have your screen set back to, state zero, and that's inconvenient. But I shared an example before of the IoT space where you're setting up hardware with your mobile application, and you could leave your hardware in sort of intermittent state, an irrecoverable state, if your ViewModel state machine is wiped out. As far as exceptions go, you could have, let's say you have other network systems that are reliant on data coming from your ViewModel. Um, there's a lot of edge cases that could happen if you don't account for process death. Next question. How do you provide ViewModel with SavedStateHandle if you use Dagger? The good news is there is a way to support SavedStateHandle with Dagger. I know most applications these days use some form of dependency injection, especially Dagger. It's kind of a must if you have large, complex applications. The discussion of Dagger and SavedStateHandle is a little outside the scope of the timeline today and this discussion, but there is definitely documentation on it. People have done this before. So if you search for this, there's quite a few references you can find on using SavedStateHandle and Dagger. Next question from Wilhelm. Would your presentation be available for studies? So yes, I will do my best to upload my slides in a place where you can access them later on. We're just going to wait and see if there's any other incoming questions. If anybody has anything to ask, go ahead and throw it into the channel. All right. If not, that's it for ViewModels and Saving State.